Techniques for groundwater recharge. Flooding or water spreading. This is a method used to enhance groundwater recharge by spreading water over the surface of the land. So this method is most effective on relatively flat topography. Steep or uneven land would cause water to flow away too quickly or unevenly, making it less effective. This process involves spreading water as a thin sheet across the land surface. This helps in maximizing the area of contact between the water and the soil. Water is directed into basins or depressions that are dug into the existing landscape. These basins, often called recharge basins, capture and hold water temporarily, allowing it to percolate into the ground. For effective recharge, the soil needs to be highly permeable. Permeable soils like sandy soils, loamy soils allow water to pass through easily, facilitating better infiltration and recharge of groundwater. By spreading water over the large areas, this method increases the amount of water that infiltrates into the groundwater systems. Percolation tank or basin. It is an artificially created surface water body built on land with high permeability. Its primary purpose is to capture surface runoff and allow it to percolate into the ground, thereby recharging groundwater storage. So its key features are, it is an artificial surface water body. The tank is constructed to create a basin or reservoir that temporarily holds water collected from the surface runoff. Highly permeable land. It is built on land with high permeability, for example, sandy soil, loamy soil. This allows water to seep through the ground easily and recharge the groundwater table. Surface runoff capture. The tank captures runoff water from rainfall or other sources. The design ensures that this water is directed into the tank, preventing it from flowing away quickly. Percolation. Once the water is stored in the tank, it infiltrates into the soil beneath. This process of water seeping into the ground is known as percolation. The percolation tank facilitates this by maintaining a controlled environment where water can slowly enter the groundwater system. Groundwater recharge. The primary benefit of the percolation tank is that it helps replenish groundwater reserves. By allowing runoff water to percolate into the soil, it increases the amount of water available in the groundwater table. Check dams. A recharge check dam is a barrier constructed across a river or stream designed to slow down the flow of water. This slowdown of water movement allows more time for water to infiltrate into the ground, thereby enhancing groundwater recharge. So key features are barrier across a watercourse. The check dam is positioned across a river, stream or channel. It is typically made from materials such as stones, concrete or other durable substances. Slows water flow. By creating a physical barrier, the check dam reduces the speed of flowing water. This slowdown is crucial for increasing the time that water spends in contact with the soil. Encourages infiltration. With the reduced flow speed, water is encouraged to spread out and seep into the soil surroundings and downstream of the dam. This infiltration process helps recharge the groundwater table. The dam can create a temporary pond or shallow reservoir upstream. This stored water further facilitates percolation into the ground. Dugwell recharge involves diverting different sources of water, such as groundwater reservoirs, stormwater, tank water, canal water, into dugwells to directly recharge depleted aquifers. These are manually or mechanically excavated wells, typically having a large diameter than drilled wells. They are used to facilitate the infiltration of water into the groundwater system. Various type of water sources can be directed into the dug wells, including like excess water from the groundwater reserves, rainwater collected from surfaces like rooftops, then water stored in the tanks such as rainwater harvesting tanks or others. The primary purpose of dugwell recharge is to directly introduce water into the aquifer, which helps to replenish and restore groundwater levels. This is particularly useful in the areas where aquifers have been depleted. The water introduced into the dugwell percolates through the soil and rock layers, recharging the groundwater table. This process can be enhanced by ensuring that the dugwell is located in a permeable area. Okay, injection wells. So recharge wells or injection wells, these are wells which are designed to inject water directly into deep confined aquifers to enhance groundwater recharge. These wells are used to introduce water into deep aquifers which are often inaccessible by surface methods due to their depth and the presence of low permeability materials such as clay or shale. Water is pumped or gravity fed into the recharge well, which then directs into the targeted aquifer. The well is designed to ensure that the injected water reaches the aquifer effectively. Recharge wells are particularly valuable when dealing with the confined aquifers, those aquifers that are sandwiched between the layers of impermeable material. In such cases, natural recharge processes are limited, making artificial recharge necessary. Now, this image illustrates the concept of an injection well, which is used for artificial groundwater recharge. So first you can see the injection well, a deep well which is used to inject water into an underground aquifer. It has an injection pipe through which water is directed downwards into the groundwater reservoir. Then artificial recharge well, water sourced from an external supply such as a reservoir or treated wastewater, it is piped to the injection well. Control valve regulates the flow of water into the injection well. Then on the left side you can also see like some of the natural recharge processes are there, like precipitation. Rainwater naturally infiltrates the soil, recharging the groundwater. Runoff, rainwater that does not infiltrate runs off the surface, potentially contributing to surface water bodies like streams. Then natural recharge from stream also takes place. Water from the streams can seep into the groundwater, contributing to its recharge.